Hello friends, this video on CET NEET crash course of Motion in a Plane chapter is presented by Pratibimba Learning by Reflection. This video will have more solutions for MCQs on the chapter Motion in a Plane. Subscribe our channel and also share this video for students who are preparing for their CET NEET examinations. Let us begin with the video. The sixth question says, a body is whirled in a horizontal circle of radius 20 centimeter. It has an angular velocity of 10 radians per second. What is its linear velocity at any point on circular path? According to the given question, let us draw the relevant diagram. The question is very simple and it is easy to solve if you know the formula here. It is told that the body is moving in a circular path. Let us say it is in a horizontal circle. What is the radius of the circle? It is 20 centimeter. I'll write r equal to 20 centimeter. It has the angular velocity of, angular velocity is represented with the symbol 10 radians per second. What is its linear velocity at any point on the circular path? Here we have to find what is the linear velocity at any point. You know that the linear velocity for an object that is revolving in a circular path will be constant in magnitude, right? So we have to now find the value of linear velocity. Since radius is given in centimeter, we need to convert it into meter. We get 0.2 meter. How are radius, angular velocity and linear velocity related to each other? We have the formula V is equal to R into omega. Right? What is R? It is 0.2. Omega is 10. Hence the answer here is 2 meter per second. The right option among the four given options is, it is 2 meter per second. Next one, question number 7 says, a bullet is fired from a gun with the speed of 1000 meter per second in order to hit a target that is 100 meter away. At what height above the target should the gun be aimed? Resistance of air is considered to be negligible, and also the value of G is given as 10 meter per second. So we will also draw the relevant diagram here. A bullet is fired from the gun. The speed by which the bullet moves is given to be 1000 meter per second. Let us say the speed of this bullet, whose initial velocity is told to be 1000 meter per second. So the gun is over here and the bullet has been fired from it. The speed in which it moves is 1000 meter per second. So the target is 100 meter away. Let us say the target is somewhere over here. Okay. At what height above the target should the gun be kept? Here is the height above which the gun needs to be kept. You know that when any object that is moving in a space is going to have its curved path. If it needs to hit the target means it will follow the curved path. So of course the gun needs to be held at some height, right? That is how it will hit the target. We are not bothering about the resistance of the air here, and the acceleration due to gravity is given in the question. Acceleration due to gravity here is 10 meter per second square. The other data, what about h? H is not given, that is what we have to calculate, the height above which the gun needs to be held, right? What about the distance at which the target is present from the gun? The distance from the target to the gun is 100 meter. Next, by the data or the basic formula we know, we can write the distance traveled. I'll write the distance traveled with the symbol is it S is equal to d by t. What is t? It is d by s. What we are going to do here is, let us find the time taken by the bullet to hit the target first. What is distance traveled? Distance traveled is nothing but the range, right? It is 100. And what about the distance? What about the speed? It is 1000 meter per second, and you have 0.5 seconds as the time taken for the bullet to hit the target. Notice that for horizontal motion, the velocity u is constant at any point, every point during the projectile motion. The horizontal component of velocity remains the constant, whereas only vertical component will change. So now let us find the vertical distance. For vertical distance to be measured, you have the initial velocity to be 0. Yes, initially before firing, the bullet moved with 1000 meter per second, but the gun and the bullet initially they were at rest, correct? That is why initial velocity will be 0. You have s is equal to ut plus half at square, or I can write h is equal to, h is nothing but the distance from the ground level to the gun. The first term is going to be 0. What is the value of a here? It is g, t is 0.1 second square. H is equal to 0.05 meter distance from the ground level, or h can also be written in centimeter since the options here are given with centimeters. I'll write h is equal to 5 centimeter. Hence option A is the correct one here. We'll go to the next question. A car takes a turn around a circular curve. If it turns at double the speed, the tendency to overturn. Let us think of car that is moving in a circular path. I mean, it is taking a curve, circular curve it is. So this is the road and the car is taking a turn. It is moving in this direction in a curved path. Okay, we know that for a car to take with this uh, uh, for a car to move in a curved path, it must be moving with some velocity, say v. We must also know that the car can move with the velocity which can be the maximum value of velocity. That is how it can be on the road and takes a smooth curve. What if this speed is doubled? If we double this speed, then there is a chance that the curve that the car needs to take may not be as expected. The car can even come out of the road. There is a force of attraction that will be attracting towards the center of the circle here, right? So if that speed v doubles, then the force of attraction towards the center will also get increased, it will be changed, right? So this tendency to overturn is nothing but the force. What is that force called? We call that force as centripetal force. Centripetal force provides the force for a car to move in a circular path. Since the car is rotating or it is moving in a curved path, the force that is going to balance the motion of the car is centripetal force. We have centripetal force as Fc, that is equal to mv square by r. If velocity itself is doubled, make a note that Fc is directly proportional to v square. What if I double velocity? Right? It becomes v dash, which is equal to 2v, doubling the velocity. It becomes 2v the whole square. What will happen to the centripetal force? The force that is driving the object towards its center. Then you can make a note that F is proportional to 4 times v square, right? That is how the tendency to overturn is quadrupled. It becomes 4 times the square of the velocity. Since you have got 4 as the answer here, what do you mean by this? The force with which the car is attracted towards the center will be quadrupled. The tendency to overturn becomes 4 times more. We'll go to the next question. A body is thrown with the velocity of 9.8 meter per second, making an angle of 30 degree with the horizontal. It will hit the ground after a time. Simply, we are going to determine the value of time of flight here. With what velocity the body was thrown? Let us say it was thrown in this direction, it was thrown up. The velocity with which it was projected is its initial velocity, right? The velocity of projection is 9.8 meter per second. It moves in a space and comes back to the ground. With what angle it was thrown? It is 30 degree. It will hit the ground after a time. So here we have to calculate the time. What is the formula to determine time of flight? Time of flight t is given by the formula 2u sine theta by g, right? With the data given, we know the value of u, the velocity with which the body was projected. Theta is also given 30 degree. Acceleration due to gravity, if it is not given, we are going to take it as 9.8 meter per second square. Substituting the values, 9.8 into sine 30 degree divided by g is 9.8. Here 9.8 and 9.8 cancels. 2 into what is sine 30 degree? It is 1 by 2. Hence, time of flight, that is the time taken to complete the total path of an object, the total distance traveled by the object has taken a time of 1 second. The right option here is option C, 1 second. Moving on to the last question of the chapter, motion in a plane. Dear students, subscribe the channel for more such videos which will be helpful for your upcoming examinations. A particle does uniform circular motion in a horizontal plane. The radius of the circle is 20 centimeter. The centripetal force acting on a particle is 10 Newton. Its kinetic energy is. Again, the particle is with a uniform circular motion. Or body is moving in a circular path. Radius of the circle is 20 centimeter. Centripetal force that is acting on a particle, I'll represent centripetal force, the force that is attracting the particle towards its center is centripetal force, right? It is given to be 10 Newton. Its kinetic energy needs to be calculated. What is the formula to find the centripetal force acting on a particle? It is mv square by r. V is the velocity and r is the radius of the circle. Fc is 10 mv square. Since we don't know the value of mv square, let us write them as it is. What about c? What about r? 20 centimeter, right? It is nothing but 0.2 meter. I'll write 0.2. 10 into 0.2 is equal to mv square. Hence, mv square is equal to 2. Let us keep it aside. What do we have to find now is kinetic energy. Kinetic energy is given by the formula half mv square, right? It is half into mv square is 2. Kinetic energy is 1 joule, or simply I can also write this as 1.0 joule. Hence, the correct option among the 4 given options is option D. It is 1.0 joule. For more videos, subscribe the channel Pratibimba Learning by Reflection. Thank you for watching.